Looking like all systems go?
Yes.
Great.
Absolutely.
Okay. Well, look, welcome back after that interesting and insightful chat from Jeff. Now, here in the Pendle Suite, we've got Element presenting, one of our sponsors here. So please give a very warm ComCon welcome to Matthew Hodgson.
Thank you, everybody. Thanks for coming to hear about the amazing world of Matrix and where we are taking Matrix to the logical conclusion of immersive, interoperable virtual worlds built on top of Third Room. So this is not our normal bread and butter in Matrix. I'll give a quick introduction to Matrix in case anybody isn't familiar, and then jump into some of the crazy science fiction that we've been up to with a tiny subset of the Matrix and the Element team over the last year or so. So first of all, if people don't know what Matrix is, we are an open network and an open source project publishing open protocol, lots of open, for secure, decentralized real-time comms. Now, you can use this for interoperable chat, and indeed, participants in ComCon are hopefully playing around with the Matrix chat rooms that have been set up for the conference. You could use it for VoIP signaling to replace the evil darkness of SIP, or heaven forbid, H323, with something a little bit more modern and multi-party aware. You could do open communication for VR and AR, as we're going to talk about today. And you can even use it as a real-time IoT data fabric for any kind of structured data. But today, we're going to talk about VR and AR, as you can see from Amandine ominously hovering next to me. So, the point of Matrix, though, is to build the real-time communication layer of the open web. We think it's a bit of a shame that communication on the web has been so comically fragmented between the different silos, whether that is between WhatsApp or Slack or Discord. Let's face it, instant messaging and VoIP particularly is relatively hard. It could have been part of the commons of the web. It could have been there with SMTP and HTTP and TCP/IP, but instead, even the very earliest bits of VoIP on the web, things like See You, See Me from Cornell University, were already not standards-based. They were basically proprietary or little apps, and as time went on, they ended up just getting more and more fragmented. So Matrix is our attempt to roll back the clock and provide a ubiquitous communication layer for the web itself. The whole idea is that no single party owns your conversations, and that conversations are replicated across all participants, so there cannot be a single point of control or failure if you're communicating over Matrix. Practically speaking, we have a full mesh of servers. The blue dots here are Matrix home servers, which store your conversations. The green dots are Matrix clients, which connect to these servers in order to interoperate together. Then you have application services, which allow you to glue additional capability onto those servers. Then you've got the Matrix identity servers, which go and map phone numbers and email addresses through to Matrix IDs, so you can find people on that network. So a typical thing people might do is to use application services to bridge through to Telegram or XMPP or Discord or IRC or many other networks. Now, this is where it starts to get more interesting, hopefully. This is today's open source Matrix ecosystem. And the main building block we provide is the Matrix spec itself. And this is there on spec.matrix.org, a whole bunch of open API and Markdown that explains how you use the APIs, which connect the clients at the top to the servers at the bottom. On the server side, we provide Synapse, a Python and now Rust implementation of Matrix. You have Dendrite as a Golang implementation that we use for embeddable Matrix. So if you had an existing project and you want to embed a Matrix server into it, then use Dendrite. Then you've got the Matrix application services and bridges for gluing on connectivity to other systems. Then on the top, you have many different clients. And the green stuff is published by us as the Matrix Foundation. You have the Matrix JavaScript and React SDK, on top of which Element Web is built. You have the old Objective-C and Swift iOS SDK, on top of which Element iOS is built. And you have Element Android sitting on top of Matrix Android SDK 2. And then finally, you have two new generations of client SDKs. One of them is called hydrogen, which is the lightest element. And hydrogen is built to basically power progressive web apps. So the entirety of Hydrogen SDK, including the end-to-end encryption, I believe is around 100K of code. So it is tiny, complete with a full WASM end-to-end encryption implementation. On top of Hydrogen, you can then put a UI toolkit that gives you typical things like, I don't know, chat rooms, heaven forbid, or contact lists, or VoIP infrastructure. Then you've got, on top of that, various apps. We have Hydrogen itself, which is imaginatively a PWA, and thanks to iOS now supporting PWAs complete with web push, you can even use it as a mobile Matrix client complete with push on iOS. You have Chatterbox, which goes and embeds it into existing sites, a bit like Intercom. So you've got your existing website, and you want to plonk a little embedded snippet of JavaScript to get your Matrix chat room in there. Chatterbox is your man. Third room, which we shall be talking about for the rest of the session. And then finally, worth noting, we have the next generation of native Matrix clients, Element X, our imaginative name for it, which are built on Matrix Rust SDK. So what we've done is to standardize the three completely different non-overlapping code bases here, unify them in Rust, use native Rust encryption implementation called Vodozabats, which apparently means amphibian in Croatian, according to my Croatian encryption developers. And then on top of Rust SDK, you have very lightweight but native UIs in Swift UI or Jetpack Compose, which go and lean on Matrix Rust SDK for all the heavy lifting. So that is a tour of the Matrix ecosystem as it stands today on the open source side. In purple, we have an awful lot of third-party projects running around. We have Conduit as a native Rust server. Even eJabberD has implemented Matrix alongside XMPP and Erlang. You've got an Elixir server called Polyjuice, a C++ server called Construct, many other bridges and bots to basically anything. I think we've got over 150 bridges now. So if you desperately want to bridge through to KakaoTalk or Line or WeChat or ICQ or whatever it might be, you can pick up some third-party bridge to do that. And there are loads and loads of third-party clients because the clients are dead easy to do. Matrix is quite asymmetrical in that to send messages, you just do an HTTP put. To receive messages, you do an HTTP get, and that's it. So your simplest Matrix client can be a few lines of bash if you want. And as a result, Thunderbird and native Apple Watch clients and various command line ones or Qt or GTK native apps exist as well. And I'm sorry about the vertical alignment there. So, Matrix as a network, we just hit 100 million total Matrix IDs as of about 2 weeks ago. You can see us going through the y-axis there. Thank you very much. So that's a bit of a breakthrough for us. You can see the general shape of things over the years since 2018 on the bottom left. Now, it's a VoIP conference. Let's talk a little bit about real-time comms. We announced this actually for the first time at ComCon, I think 2 years ago, at which point it was somewhat vaporware / science fiction / speculative. But the whole idea is to support native VoIP signaling over Matrix, not just for one-to-one, but also for multi-party communications. And the idea is that your Matrix clients, rather than just sending messages through to chat rooms, would go and send signaling messages through, which would negotiate the orange media paths over plain old WebRTC media. So really being the missing signaling layer for WebRTC. The actual sequence diagram I should have probably thrown up looks a bit like SIP. You do an invite, you get an answer, you trickle some ICE candidates, you send some candidates back and forth, and then somebody hangs up from one side or the other. However, you can do as many of them at the same time as you like, and so in the simplest case, you can end up with full mesh voice conferences and video conferences between the various different participants, or if you have an SFU function or a focus, because it could be a selective forwarding unit or it could be a multi-point conferencing unit, you can go and bridge these guys together server-side. And the fun thing is that just like the servers in Matrix, these can be heterogeneous, decentralized, run by different people, by different vendors, don't have to trust each other. So you can have decentralized cascading focuses or foci run by different parties so that these guys might be mixed together on this server. They will then trunk a single WebRTC call with multiple streams through to other servers. These servers go and subscribe to the streams depending on whether they want to see thumbnails or full resolution or nothing at all. And you basically end up with a big decentralized switchboard provided by these focuses that the clients can go and connect into. Now, we'll be talking about that in a talk tomorrow, so if you want to geek out on plain old end-to-end encrypted cascading selective forwarding units, then go and see Dave Baker's talk, which I think is tomorrow, and he will demonstrate all of that. We've also been experimenting with LiveKit as a way to short-circuit the focus function and basically use LiveKit SFUs as that component in the network, and honestly, it's working incredibly nicely. The reason I mentioned Matrix RTC, though, is that one of the more exciting things you can do with Matrix RTC is use it not just for VoIP, but for VR as well. So, as we've said, Matrix is a decentralized comms layer for any kind of real-time data, and Third Room specifically is this tiny project done by Robert, Nate, and AJ, who work at Element, doing this on behalf of the Matrix Foundation, to provide an open, decentralized platform for spatial collaboration. Note that we are not using the dreaded metaverse word here anywhere. The idea of Third Room really is just to provide an open layer for any kind of multiplayer, multi-party, real-time spatial collaboration. Now, it's built on Hydrogen, as I mentioned earlier, and it glues together a couple of other libraries into a new engine that we've imaginatively called Manifold. And the libraries it glues together is 3JS, which is a JavaScript library for manipulating WebGL and WebVR for actually rendering stuff in the browser. BitECS, which is an entity component system built by Nate, as it happens, which basically models the state of the world and provides the framework for replicating it over the network, over Matrix. And finally, Rapier is a physics engine, so that having created your virtual environment, you can have Newtonian physics or Galilean physics and go wild. Tragically, we do not have relativistic physics yet. So the idea is that you take a Matrix chat room, you upload some GLTF, which is the transfer format from the Kronos group for OpenGL, and everything in Third Room operates on GLTF. It's a good open standard. It's no way to go and describe 3D objects. And you put these literally as files in the chat room, as if you've just sent them into the room. Then you upload some WASM, or some JavaScript scripts, into the room as well. And this, weirdly enough, defines how that room will behave and the application, effectively, that runs within it. Finally, use Matrix RTC to set up spatial VoIP and data channels and the physics synchronization over WebRTC. So we're using it both for the spatial voice collaboration in that space, but also the super low latency data channels that you need in order to make sure that the physics all lines up. So the end result is that you get web-first, open, decentralized virtual worlds and spatial applications without any cryptocurrencies or a single point of failure dependency on Facebook. So, what can you use this for? Many people say, oh, this is cool and all, but who the hell wants to use this? I'm not going to read through this entire list, but this is literally me just brain dumping at some point, trying to think of the sort of things that you could do on it. You could do virtual events. Imagine if rather than the poor people watching this stream, they could actually be sitting in the audience and having an immersive experience right now. You could have telepresence. Why don't we have proper 3D video calling even today with even today's headsets, let alone the fancy Apple ones on the horizon, have got 3D cameras in them. And I think even for the Apple Vision Pro, they're not actually proposing yet proper holographic 3D video calling. Instead, it renders it using a persona. Hanging out online, jamming together is a really fun one. Just collaborative art, gaming, obviously, entertainment, social viewing, online relationships, like long-distance dating. Disaster management is a huge thing, particularly when you've got loads of different emergency services who don't coordinate at all pile on in an environment where there isn't any good connectivity. How do they collaborate today? I can tell you that they use WhatsApp right now, and if somebody goes and sends up a drone and takes a bunch of LiDAR scanning to try to figure out what on earth has gone wrong, they end up with about 4 gigabytes of LiDAR points on a phone. And they say, OK, who can I send this to? And there is no common language, common platform for going and collaborating on this sort of thing. Similarly for GIS, smart cities, visualizing where things are, healthcare, education, blah, 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 blah. You get the idea that the web really could do with a 3D spatial layer, as well as the plain old DOM that we have today. So you can really think of Third Room as a complement to the web itself. On the web today, we have HTML, in which you describe documents, the DOM API, with which you manipulate documents, JavaScript or WASM, with which you write some applications to make things go even better. And if you want real-time communication on the web, obviously you use WebRTC, and I hope you use Matrix to signal it. Meanwhile, on the Third Room side, you really have an equivalency with GLTF being the file format that describes the spatial state of that world. And we have created a new API called WebSG, Web Scene Graph, which is to GLTF as the DOM is to HTML. Some people say, oh, why don't you just use the DOM? The thing is that the DOM API is great and all-ish, but it's very much designed for XML or SGML or HTML, whereas scene graphs are just intrinsically different. If you go and try to manipulate the state of a GLTF file through the DOM, sure, you can do it, but it's a horrible mismatch. Then we provide WASM sandboxes to go and define any kind of scriptable applications within Third Room. So rather than using the browser's normal JavaScript engine, we're very consciously running stuff within a very locked-down WASM environment, within which we can put JavaScript. And we compile it down to WASM using Quick.js, which is an amazing little library from Fabrice Bellard. Or you can write in C or Rust and Zig and go and write your apps and compile them to WASM and then run them in this virtual environment in such a way that they will not be able to bust out and start reading your chat rooms in Matrix or reading your end-to-end encrypted messages or stealing your end-to-end encrypted keys, because everything is running in its own resource-constrained sandbox. And then for real time, obviously, it uses Matrix and WebRTC. Last week, we launched Tech Preview 2, which adds web scene graph and scripting. It adds WebXR support, it adds a inspector UI, it provides a directory for finding content and worlds, strange new worlds, if you will. Also has a new kinematic character controller. There are some things missing, though, because the project is still in beta. Critically, we don't persist the world yet, which is a bit embarrassing, but it's easy enough to do that when you edit the GLTF, we need to store a diff into the Matrix room so that you can come back to it later. Mobile support is big. Turning the inspector into a full-blown editor is ongoing. I'll show you it in a minute. Custom avatars are actually being contributed from the community, so thank you people in the community who are figuring out all that stuff. Having a bunch more apps and then more engine features like shadows and other fancy bits and bobs. So, enough talking for me. Let me show you what it looks like. So if anybody here can go to thirdroom.io right now, and you will see something that looks like this. On the left-hand side, you have the hydrogen room list, and you've got a whole bunch of different worlds or chat rooms that I'm in. And I know I can hop into one like UK City, which has got 1,076 people who at some point have been roaming through it. And assuming I've got enough internet connectivity to I've got downloading stuff at 28K a second. This is going to be quite painful. Well, hopefully it will come up in a minute. There we go. And if I bring up the frame counter here, you can see this is doing roughly 60 frames a second. I think my laptop is doing something a little bit special here, based on the CPU. Yes, ClamD. Thank you, Clam. This is the perfect moment to do a massive antivirus scan. Let me just go and kill -9. Clam. If I could only type. Right, does that help things at all? Yeah, maybe. Oh, God's sake, this is going well. What? There we go. Well, hopefully that will help a bit. Otherwise, I mean, you can still see the frame rate is relatively good here. So this is a fairly photorealistic view of a fake UK environment. And if I go into fly mode, I can zip out, and you can see that it's actually a single blob of GLTF, and we can see the corners of the world fairly clearly down here. If I go and jump back down again, And I don't know if anybody out there is thinking of following along on this and perhaps joining me in the world half short. If you're just sitting there in the audience, then there may be some people to go and demonstrate against in here too. What I can show you though, whilst I wait to see if anybody turns up, is that we've got the physics engine where I can go and create some objects. And comically, there we go. Here are some crates that I've just gone and spawned. And I can go and create some more ones, so to speak, some more ones like that. Each world has got a limit to the number of crates that you can create. You can go and pick them up, run around, you can throw them around the place like so. And also, heaven forbid, delete them and mess around like this sort of thing. Now, at any point, I can hit enter in here and say, hello world, this is Matrix, and I could go over to UK City on my element here, and go and join UK City there. You can see, hello world, this is Matrix, hello everyone, and the message, oh, there's Dave saying hello on the element side of things, and that comes through to Third Room like so. Oh, and there's Midu out there also saying hello Matrix. Hopefully folks are actually wandering around this world too somewhere. Whilst I'm here, let me actually switch over to a presentation world. So in presentation world, which has got far fewer people in it, and might be easier to find other people within the maze, then this is a kind of sci-fi scene, and it's actually being created in Unity. In fact, it's a paid Unity asset. And we've written a pipeline that allows you to export Unity scenes through to GLTF, so you can just grab them straight into Third Room. And within here, which is hash presentation on thirdroom.io, if anybody wants to turn up, and there's Dave. Hello, Dave. You got audio on. Can you hear me? Anyone out there? You might just about be able to hear the wind noises of the emptiness in Third Room here, but if Dave had unmuted himself by hitting the M button, then I should get... Oh, there we go. Hello, Dave. Can you hear me? Okay, well, you can hear me like walking around the place there. And comically, the input has got stuck here, so I need to just refresh briefly, and we'll go back to Dave in a minute. Oh, there we go. So you can see him standing over there. As it happens, he's actually on a different server. I'm on thirdroom.dev, on the dev server. He's walking around on his avatar on thirdroom.io. Now, this thing here is a presentation using WebSG to do a really basic view of the world, where if I hit next, I can show you what's actually going on under the hood. So we've got 3 threads flying around here, because as you can see from my poor CPU melting on the top right, this is properly multi-threaded to bring it up to the 60 frames a second. You've got a main thread, you've got a worker thread, and you've got shared array buffers, which are used to synchronize using atomics between the various worker threads in the main thread. So this is the big techie breakthrough of the manifold engine, that it's using triple buffers effectively to go and synchronize asynchronously between multiple different web workers for doing physics, for doing the WASM, and for actually rendering out the WebGL stuff. So on the main thread, you've got React, you've got Matrix, you've got WebRTC happening. And then on the game thread, you've got the Rust running Rapier for the physics engine, and it's also where the WebAssembly things work, like the little script, which is going and letting me sort of skip through the slides here. And then on the render thread, imaginatively, you've got WebGL run using 3JS, and also WebVR in order to render in a VR environment. And the whole idea is that in normal game networking, you basically have the game thread that goes and updates state, and synchronously in a single thread will then hand through to the renderer, whereas in a triple buffered approach, you can have multiple threads going and updating a shared buffer in a lot-free manner, and the render thread can run at its own speed. So even if you're only updating the thread, the game thread every, I don't know, 10 hertz or something, if you're viewing it on a 120 hertz monitor, then you'll get the maximum frame rate up without ever being limited to the throughput of the other threads. We've done a lot of work around asset optimization so that it will run, hopefully, on Oculus hardware, which tends to be pretty low end. So this whole scene is about 40 megabytes of GLTF. But for instance, we are compressing all the assets and putting it on a single sprite. We have pre-calculated shadow maps and things around the place. So if I go and create a mirror ball, like this guy, and chase it down, and pick it up, and then I run around the world with it, you can see that I'm hitting myself in the face with it, rather embarrassingly, because I'm running too fast. But as you move around, the reflection changes slightly. It's not perfect, it's not ray traced, but as you go out into the garden, you can see that surroundings have now changed in the mirror ball, because we're basically pre-calculated reflections from different bits of the world. And the same thing happens with shadows as well. So that you basically get plausible ambient lighting. And I'm going to throw that at Dave. Bing. And so lots of fun on the asset optimization pipeline. If you're wondering what was happening under the hood, if I go into fly mode and I literally look under the hood, you can see that this presentation was actually done by putting the slides under the world and then having a tiny bit of JavaScript that will go and flip things in and out. Should we do a quick VAR demo, or is your thing going horribly wrong?
It's horribly wrong again.
Do you want more time, or shall I go and talk about other things?
Same issue as earlier, I don't know.
Okay, well, whilst you... how do you get out of it last time? Press this thing. The Oculus things can be quite painful to work with, and hit quit and then get back in. So, let me think, what shall I show here? Let me try going to VR anyway. So here's one that I made in theory earlier. Oh God, this demo isn't going well today, is it? Right, casting stops, that's a great start. Let me go and grab my Oculus and turn this on, and hopefully I'll be able to just cast so you can see what I'm seeing on it, if it hadn't randomly stopped. And because the thing is that the Quest Pros have within them, God, everything is going wrong, it won't calibrate my controller at all. The Quest Pros have a web browser built into them, which is Chromium-based, and it has the whole WebGL and WebXR stack on it. And I'm hoping that in the next 10 seconds or so, this thing will actually start casting, and you can see what I see. And so you can actually go straight into Third Room as a normal WebXR app. Is that working? There we go. Oh, that was painless. Okay, so hello, everybody. And you can see what I see here. So let me go full screen on this. Bloop. Right. And if I look down here, I can go and pull up a browser, and this is, no, I'm not going to update my browser now. You can see the Chromium view of Third Room just sitting here hovering as a virtual screen, assuming that it comes up. Let's go and refresh. And the app that I'm going to take us into is imaginatively called Flight Deck. And Flight Deck is a WASM app that we've written that visualizes flight path data in real time. And I'm just going to need to make sure that it's running right. And what this thing should do, again, assuming that the demo gods don't completely destroy me, there we go, is to show you a map of Geneva. And it starts off just a normal 2D, but if I go and press the Alt-X button down there, and I go and calibrate this like so, then you will see that I have an XR map of Geneva sitting right here. And if Amandine is with me, yes, no? Then hopefully if you turn up and calibrate, in fact, you can see that we're not calibrated yet. You have to actually go and click a thing in the same place in order, there we go, to synchronize our worlds. But if we do, then we will both be looking at the same XR view of things at the same time. You can see we're not perfectly calibrated here, so we're rendering her headset a little bit off to the side, but in terms of collaborating in the same environment, we can look at these planes which are flying around, and you can see the flight path of this guy here. Ah! God, what a nightmare. Right, let me get out of this and start recasting. When did it drop?
That's just now.
Okay, well, it still thinks it's casting. Trust me, I think this might work even better if this is possible once the Apple hardware comes out. So has that come up yet? Well, whilst this thing comes up, perhaps, yeah, what I can do is, there we go. So it's come back up there. You can see Amandine, and in fact, I can look through her head at the headset there. But what I could also do is to pop into Third Room itself and see it from a 2D view too, because you don't want to just be limited to what's happening in VR. If I go over to Flight Deck GVA here, then, again, assuming there's enough connectivity. Oh, you can see here's some very confusing spatial audio because one of us isn't muted. I'm going to hit mute there and turn around, and you can see that there we are wandering around the place from a VR perspective too. So literally, as I wander over to the virtual one here, you can see me coming over to it in the 3D space as well. So you've got a mix, basically, of the 2D environments, and here you can see Amandine going and hopefully clicking on planes within that view. Let me go back to my view of the world, if I can find the right tab, which is hard to see when you've got a headset on. All right, so now you've got me there. So this pink thing is virtual me sitting from the browser-based view of the world. So hello, virtual Matthew. You've got Amandine there, but with the overlay of her headset there. And then you've got that I'll get rid of. And you can see, hopefully now more usefully, that we can collaborate on this. We can go and click on the planes, and this will tell me that this is EasyJet EZS 437, or whatever it is, altitude of 10,000 foot, coming in, and presumably it's going to loop around Lake Le Mans. This guy's coming down the path of Lake Le Mans and is going to land on Geneva Airport there. We normally use the Bay Area for this, but at this time of day, the Bay Area is dead because it's the middle of the night, so instead we're using Geneva. If I get down lower, then you can see that we've got proper altitude here. In fact, you might even recognize. Oh, okay, Facebook does not like me. I shouldn't have plugged the Apple hardware. But you get the idea of the fact that you basically have a spatial collaboration. Yay! Environment there. Thank you, Amandine. So, what else can I show you whilst we're in here? How am I doing on time? Do I have a...
Right near the end.
Right near the end. Okay, let me very quickly then show you the new stuff. Because what could be particularly fun here is if you press the backtip button at any point, then you can go straight into a direct manipulation of the world. So I, for instance, can go and click on objects within here, like the scene, and it allows me to go and drill into the GLTF scene graph and start manipulating any aspect of this. So I can select this thing, and I can toggle whether it's visible or not. I mean, that one's not very exciting because it was the glass of the window, but as you can see, I'm basically toggling the window glass on and off at the moment. Perhaps I might go over to the board here and look at some objects here. Again, hit backtick. And I might go and select that plane if I can get him, or, yeah, there we go, go and find an interesting plane to click on. So there's that one. You can see in real time that the bridge data is going and updating the position, or at least it should be updating the position unless something horrible has happened to that plane, in real time. And I could actually go to this URL here, go over to normal element and join it. And the data for the location sharing should be visible in here as basically location shares in real time, but because the demo gods are destroying me, I apparently don't have that. I'll go and send a message in there, so the hi will be coming through on the room. You can see this guy is finally landing there. You'll have to believe me that there's a whole bunch of location share data that should be visible if it wasn't randomly hidden. So you can see the same structured data in Matrix and in Third Room. And finally, if we go into the script editor, we actually have a full Visual Studio code via Monaco embedded in this, so that if one wanted to start editing the JavaScript that defines that little app, then you can see the stuff here of, I don't know, how do you set the axis of the planes, how do you do a linear interpolation between things, a bunch of matrix operations, etc. This one was actually written in TypeScript, so here we're looking at the JavaScript, which has been Babelified down to JavaScript from TypeScript. But if I go to a much simpler scene, let's go to this guy. It wouldn't be Matrix if we didn't have a scene like this. Then let me bring up the editor, and you can see that the script here is much simpler. With when you load the scene, it goes and finds a node called TV, it makes it interactable, and then for every frame it checks to see if you're clicking the TV, and if it is, it toggles the data to the TV and makes that object matrix material, which is an Easter egg that we've built into the engine. And predictably enough, that means that if you go and click on the TV, then, hey presto, you end up with a silly matrix view of the world with everything in swirling green colors. So, I mean, that's the idea, that basically you have the scripting engine sitting in there, and you can go wild, going and adding in whatever functionality you like. You can even script Matrix from within it using the Matrix Widgets API, where you have permission-based access to send and receive messages, edit room state, and generally directly manipulate the whole world. So that's Third Room. Hope it's interesting. If you want to do anything in 3D, please build it on Third Room. Thank you.
Okay, now we're just going into a break. I think the microphone's going to come on before too long. There it goes. We're just coming into a break. We're going to be back in here at 11:15 for Henning. I just saw Henning sneak in at the back. Hello there, Henning. He's going to be talking about what's going on in the Kama Ilio project. In the meantime, let's give a very big thank you to Matthew and Amandine. And if you have questions for them, then they will be milling about. So feel free to make your way to them in the break. See you back at 11:15. Thanks.